Right, going to have a wee look at mixed numbers and overloaded fractions. In the real world, the reason we have the two is mixed numbers tend to make more sense to people, so they're the numbers we quote. But all our rules for addition, subtraction, multiplication, division, they work well with your overloaded or improper fraction. So if I get my pen going, and I start with something like this, if we do these ones first, we'll call that number 1. 2 3/5, and I want to convert it into an overloaded fraction. The bottom line is not going to change, that's like the currency, it's fifths. On the top line, I'm going to go 2 times 5 plus 3. Now the 2 times 5 is relating to what I've got here. There's two whole numbers there, and in each of those whole numbers I've got 5/5, so I go 2 times 5. And then I've still got 3/5 extra, so I have plus 3. And so I'll write that as 2 5s are 10 plus 3 is 13 over 5, same thing. So if I go down to this one, set it up, that's the bottom line, that's not going to change, so I write that in. It's fourths we're dealing in, that's the size of fraction. On the top line I've got 4 wholes here, so I'm going to go 4 times 4, so there's 4 quarters in each hole, and I've got this one here that's extra, so I'll tack it on. Now 4 4s are 16 plus 1 is 17 quarters. 16 of those quarters are made up in the 4 whole numbers, and that's the 4 times 4, and then I've got the 1 left over. This one here, bottom line is 7, so I put the 7 in. It's sevenths we're dealing with. The whole number here is a 6. So each of those 6 whole numbers have 7 sevenths, so I've got 6 times 7, and I've got another 3 here, so I'll put plus 3. And that goes 6 sevens are 42 plus another 3, 45. And the bottom line's been decided long ago. It never changes, it's always 7. So that takes care of that. That's moving from a mixed number to an overloaded fraction, and I would do that if I wanted, particularly if I want to multiply, add, subtract, then it's the best way to go. Moving with something like this, I'm moving to a mixed number now, so I'm starting on this one with, we'll do this here, 15 over 4. I say to myself, how many 4s fit into 15? I've got to do a bit of times tables. 1 4 is 4, 2 4s are 8, 3 4s are 12. If I go 4 4s, I'm over the top. So 3 4s, so I know that 3 times 4 equals 12, that's a times table. So, and if I go any bigger, more 4s, I'm going to go over 15. So I've got 3, and it's going to be quarters. Whoops, I made a bit of a mistake there. That's going to be a 4, but on the top line, rub that out. 3 4s are 12, so I've used up 12 of that 15. I've got 3 left over. Let's see if I can make it a little bit more tidier. So 21 fifths. 5 times 4 is as close as I can get to 21 without going over it, if I'm going to use 5s. So I've got 4. I've got 1/5 left over that I haven't used, because 5 times 4 used up 20 of the 21, and so I've got the 1 left over, so 1/5. Now 100 goes into 6. I did this one in class today, and I got a good suggestion for one of my students. Start by simplifying, so 50 over 3, same thing. And then how many 3's go into 50? Well, this is not so tidy, but here's an interesting fact. 3 times 16 equals 48. Now you need to know a bit of multiplication perhaps to know that. So I've got 16 whole numbers, and I've used up 48 of my thirds, so I've got 2 left over. So I leave it like this. Not going to worry with the algebra on this, because really this is a number issue. Okay?